Hello, David Smith here. Welcome to my home tutorial. Today's lesson is going to be on quadratic equations in electrical circuits. Okay, so we have the following circuit. We have an 120 volt supply with a 10 ohm resistor and a 100 watt light bulb connected in series. Now for this example we are asked to find the current I. Now at this point it would be useful to actually make a sketch of the diagram. So I'll give you a few seconds and then I'll come back and carry on working through the example. Okay, so step 1 is to apply Kirchhoff's voltage law to the circuit. So V equals 120. So this equals the voltage across the resistor plus the voltage across the load, which in this case is the lamp. So this can be labelled as equation 1. We then represent the voltage drops across the resistor and the light bulb in terms of the current I. So Ohm's law gives us V R equals R times I. So the voltage across the resistor equals the resistance times the current. And this equals 10 ohms times I. So this can be labelled as equation 2. Now the power equation for the lamp, PL equals VL times I, which tends to VL equals PL divided by I, which equals 100 divided by I, and I'll label that as equation 3. Okay, so I've made a note of the voltage equations on the right hand side. Now step 2 is substituting from equation 2 and 3 into equation 1, and this gives 120 equals, so we substitute VR for equation 2, so it's 10I plus substitute VL for equation 3 into equation 1, 100 divided by I. Now if we multiply through by I, we will get rid of this this fraction. So we say 120I equals 10I squared plus 100. So if we move this over to the right hand side, we get, and we'll write it as a quadratic as well, we get 10I squared minus 120I plus 100, and that equals 0. We'll label that as equation 4. Okay, so we now have our quadratic equation. So now I'm going to look at solving this using various methods. Okay, so I made a note of the quadratic equation on the right hand side. The first method I'm going to use to solve this is the formula, which you should all be familiar with right now. So we're going to say I equals, B is 120, so it's 120 plus and minus the square root of B squared, which is 120 squared, minus 4 times A, which is 10, times C, which is 100, and divide that by 2 times A, which is 2 times 10. So doing the maths, we have I equals 120 plus or minus 101.98 divided by 20. And this equals 11.1 and 0.901, and they are amps. Okay, so how is it that our circuit have two different currents? Well, actually it doesn't. The power of the light bulb is rated at a specific voltage, so only one of the currents is correct for the given light bulb. So let's calculate the voltage and resistance of the light bulb at each of these currents. So A, we have I equals 0.901 amps, which tends to VL equals PL divided by I, which equals 100 divided by 0.901, which equals 111 volts. So therefore we have the resistance of the lamp, which equals VL divided by I, which equals 111 divided by 0.901, which equals 123 ohms. So we have B, I equals 11.1 amps, tends to VL equals PL divided by I, which equals 100 divided by 11.1, which equals 9.01 volts. Then RL equals VL divided by I, which equals 9.01 divided by 11.1, which equals 0.812 ohms. So I will now tabulate these results, and this will give us a clearer picture of what is happening in the circuit, culminating in identifying the correct current for the load that we have in the circuit. Okay, so here I've tabulated the results. You can see we have our currents on the left hand side, so we have 0.901 and 11.1, which we previously calculated. The voltage across the resistor is 9.01 for the 0.901 current and 111 volts for the 11.1 current. Now I've calculated the power of the resistor as well. So the power for the current at 0.901 is 8.12 watts, and as you can see for this current it's quite a large value, which is 1.232 kilowatts. The resistance of the lamp is given there, so the resistance is 123 ohms at 0.901 amps and 0.812 ohms at 11.1 amps. And this is for both currents are for a 100 watt lamp. Now the resistance for a 100 watt lamp at 120 volts is approximately 140 ohms. So the current that we're looking for our circuit is this. So that one is the correct answer. So okay, that's the end of the example. If you've got any particular examples that you would like me to work through, please put them in the comments box, and don't forget to subscribe to my channel.